Assalamualaikum and welcome to Group 4 presentation of Planktonology scientific module. Our topic is on embryonic development of climbing perch eggs in different concentrations of caffeines. A little introduction to what we are doing. Summary. So this falls under the area of science, environmental science. It has medium advanced difficulty, not that hard to do, but it also requires short times only, like 1 to 2 days. But to do this, you need to be able to focus for a long period of time because the experiment needs you to observe the fish eggs development. So to get the materials, you need to do ideal spawning to get the fish egg. And it's not that expensive, just 50 to 100 ringgits, and it's a safe experiment to do. So you can probably do it at home. Our objective in doing this experiment is to determine the effects caffeine have on embryonic development of Anabas testudinus planktonic fish eggs under different concentrations. So what we manipulate in this experiment is of course the different concentration of caffeine used, and what we want to observe, the responding variables, it's the development of the embryonic fish eggs under the period of 24 hours. What do we keep the same? That is the parameters, other parameters like water salinity or temperature and the type of fish egg that we use. So a little explanation, a background of material we are using, which is caffeine. Caffeine is purine alkaloid with a chemical structure of 137,3-methyl-xanthine and is always found in plants, tea leaves, and cocoa plants, and usually when humans drink them as coffee or something. When caffeine enters our bodies, it will be metabolized by cytochrome P450 oxidase enzyme system, which is in our liver. So it will be broken down into 3 parts: 84% paraxanthine, 12% theobromine, and 4% theophylline. This will be excreted out from our body when we urinate. So usually the amount that we excrete is like 3% from the original caffeine amount. This will go into wastewater and eventually will unfortunately end up at the ocean. So did you know that every day over 2.25 billion cups of coffee are being consumed? Humans consume an average of 100 milligram caffeine in a day. Since our excretion is like 3%, that means at least a person excrete 3 milligram of caffeine per day. This is alarming, but don't worry because in Malaysia we have proper wastewater treatment. Our main sewerage operator, Indah Water Consortium, have 3 types of dominant wastewater treatments, which are preliminary, primary, and secondary treatment. Caffeine is treated under secondary treatment using biological treatment, so it can be both organic and suspended solids. So in this experiment, how do we justify what we are doing? This experiment, we will observe the effects on embryonic development Anabas testudinus using 3 different concentrations of caffeine, which is 0.05, 0.25, and 1 milligram per liter. And why do we choose this specific concentration? That's because a similar experiment has been done using zebrafish eggs before. So we are expecting similar results.
Next, let's move on to the methodology. For the materials, we will be needing coffee powder, adult Anabas testudinus, oviparim, and distilled water. Next, here is the list of apparatus that we will be needing in the experiment. For the procedure, we will be separating the procedure into 3 parts, which is egg collection, solution preparation, and fish embryogenesis. For egg collection, we will be injecting oviparim into the fish in order to obtain the fish eggs for the experiments. For the solution preparation, we will be preparing for 3 concentration of coffee in order to test the subject. And last but not least, the observation of the fish embryogenesis. For the observation, we will be using the microscope to observe the development of embryogenesis in given time. In order to fully observe and utilize the experiments, we provided a guide for future reference. A datasheet that will be needed for the experiment. You can download from the links. Other than that, we also provide a picture guide about how the fish embryonic development, and last but not least, the expected outcome. This expected outcome is taken from a different zebrafish embryos exposed to 1 mg per liter of caffeine.